Well, we're going to have a look at what's called the sine wave tracer. In fact, I'm going to construct a sine wave curve for you from a unit circle, just so that you can see how the construction's done, and so it'll be really clear in your mind. Okay? Now, first of all, we're going to look at a unit circle. This circle here is, well, it has a radius of 1, although it doesn't look like it, does it? Please just imagine it has a radius of 1. And we're going to imagine that this central part here, in the middle, is a hinge, and that we're going to move that point on the circumference, this point here, we're going to move that around the circumference anti-clockwise, okay? So let's pursue this. That's an anti-clockwise direction. That is the positive theta direction, okay? That's the first thing we've got to discover. And the next thing is we're going to look at these coordinates. We've from the origin over here, we can see that we can measure on the horizontal axis, we can measure x and we can measure y. And this is our traditional view of trigonometry for theta. Now, I'm just going to mark those as x and y there, and then in terms of, for a unit circle, which this is, I've just marked the hypotenuse in as 1, sine theta is taken to be y over 1, or just the y coordinate. Just as for cos, it is the x over 1, or the x coordinate. Now, that's how we measure sine for all of the quadrants, as this little black hypotenuse, as it is now, moves anti-clockwise around all corners of that circle, or all quadrants of the circle. Okay, that's the idea of it. Now, we're going to move on now and have a look at, there's a unit circle in the left-hand side, and I'm going to start tracing the height, or the y coordinate, as we move anti-clockwise in the anti-clockwise in the direction of theta. And along in this graph over here, you'll see I'll be tracing the angle on the x-axis, or the theta axis, that we have swept through. And I'll also be tracing the height of, or the y coordinate, on the vertical axis. And you will see before your eyes a sine wave will materialize. There we've started on our journey, and here comes the next bit, and we are moving anti-clockwise, and we are tracing out on the left the angle that we've swept on the graph, and we're also tracing the height of the red line, the vertical line, or the y coordinate of that triangle in the unit circle. You see how it goes? Now we've almost reached the zenith there, or the highest point there, where the red vertical line in that triangle in the unit circle is almost reached the length of the hypotenuse, which it will do in a moment, and that therefore would become 1 unit long, and there it is. There is the maximum value of sine, is 1. Okay? That's how it goes. Now we're going to go down the other side as we continue to move anti-clockwise, and you can see our trace is now slippery sloping down the other way, getting back towards 0 again in the what's called the second quadrant, or second lot of 90 degrees of traversing the angle theta. Okay, see how it goes? Now we're approaching 0 now. We're almost there, and just about, and there we've got it. We've actually completed half the journey round our unit circle. Now, into the third quadrant now we go, and as we see now, sine has reached negative values, because that vertical line in the little triangle, that red vertical line in the triangle on the in the circle on the left, I mean the unit circle, is now negative, because we're in the negative y realm under the x-axis. And there it goes. You get the idea? And we're approaching the maximum value in the negative now, as that red line, vertical line in the unit circle, approaches the length of the black hypotenuse. There we go, almost there we are, we're there. Okay? And that's the minimum value of the sine function is -1. So we're just going to complete the cycle now into the fourth quadrant, and we're heading backwards to home, getting backwards towards 0. That red line in the triangle in the unit circle is getting smaller and smaller and smaller, approaching 0 again. There it is. So there you have it. There is your sine wave, and you can see quite clearly how it's traced out, and there it is. Now, in terms of the quadrants, well, we have this part here corresponds to the first quadrant. As we saw, the first lot of 90 degrees. This part of the graph here is basically quadrant 2. There that is. And quadrant 3 is here. There it is. And quadrant 4, of course, is the last quarter of our circle. Now you can see how it all fits together. Now, the period of sine is the length of through which theta has got to be swept to complete one full cycle. And that, as you can see, is 2 pi radians, which is a full circle, or it's 360 degrees. And the amplitude of the sine graph is just the maximum distance that you sweep in the vertical from the central axis to the zenith, and that is basically 1 unit. Okay, it doesn't matter whether it's plus or minus, it's just 1 unit. So that's how sine goes. It's really, really interesting, isn't it? So I hope you got something out of that. It really brings it to life, I think, when you can see it traced in that way. All right, thank you so much, and see you next time.